1 second here. Everyone can see my screen correctly?
Yep, I see your screen.
Okay. So I'm François L'Espérance. I'm the head of technical support here for KingHome. I'm based in Montreal. We have done a lot of hair and layer here in Quebec since the last 30 years. So it's not a big deal for me to explain you how it works. I will give you a couple of installation tips also to help you guys to install those units perfectly for at the first time. And so don't be shy if you want to ask questions during the courses. There's no problem at all. Or we can also wait till the end of the presentation, and we can talk about everything we will see in this training presentation. So first of all, we're gonna get a product description real quick about the both different air handler that we have in offers for you on the field. Some installation tips, the dip switch configuration, electric heater installation, and as well the startup at the end of this. So let's start with a quick product description. So we have two different air handler for KingHome here. We have the first series called the KU, for example, 36 or 24 UH2 high. So this air handler is a high static pressure air handler. It comes with optional accessories. So you will have both flare connection on this kind of air handler. You will have a liquid line and a suction line flared, and they come with those pipe adapter. And just next to it, we have the KD-UHI. So this is a standard static pressure air handler. This one will come with only one flared connection. The liquid line will be flared. So you will have to braze the suction line on this one. But most, well, they've been like, the construction seems similar from one to the other. So you have your blower wheel here, your blower motor. On the top of the evaporator coil, both systems have two different drain pan, and you have the electrical board on the top here on the air handler. So if we take a quick look at the dimension, the KU, they have two different cabinet they were using. So we have a 2-ton, a 3-ton using the same dimension here, and a 4-ton and a 5-ton using the same dimension. So 24 by 21 by 57 for the heights for the 4-5-ton. And if you look here to make a quick difference with the KD, we have half tonnage available for the KD. So if we take a look at the 2-ton, 2-ton and a half, they will use the same dimension here. 3-ton and 3-ton and a half, they will use the same dimension. And we have the 4 and 5-ton here with the same dimension over here. There's a tips that I want to focus a little bit is the dimension here of the outlet supply here. So the A and B dimension here, so about 12 by 20. This is really, really important when you will fix your ductwork to match this dimension here to make sure you will have enough space, or you will be able to open the top lid here on the air handler. That will greatly help you during the installation for the duct heater. And so whenever you are installing these kind of air handler, I hardly suggest to have the dimension here for your first joint, for your first ductwork cabinet, like on the supply here, to make sure you fit this dimension. Same thing for the KD. You have the same kind of top lid here. So again, just make sure you match the A and B dimension here. Those air handler can be installed vertically or horizontally. So for upflow throw like this one, or it can be on the left side or on the right side. And this air handler is based to work only in indoor operations or indoor temperature. If it's like if you are out of range here, maybe you will have a lack of performance in the units. But the thing is, you always have to install those guys inside a room or a room where it's heating. Also, there's no side return for those kind of unit because we have a coil inside of it. So we need to have the hair coming from the bottom of the air handler. So basically, the most like all the installation that we've been here so far, we installed a kind of bed below the unit to build up the return hair. So this is this kind of installation here that you can do. So you can install like a bed just below the unit, having your return hair column on one side and your air handler on the other side. Also, another like little tips that I can give you is you can just before you do your installation, you can remove the indoor coil. So you just have to remove a couple of screw here and remove the panel. Then you will have access to the coil. You can remove the coil. That will reduce the weight of the air handler. So during the installation, and also that will gives you enough room to screw the unit from the inside. So this is really perfect to do the installation when you have a bed like this under the unit. And also it's much lighter to manage the air handler and to install it. Again, I put some notes here about the plenum size, the dock work that you will install on the top of on the air handler. So they are all the same size, like 20 by 12, except for the smaller tonnage of the smaller capacity of the KD that it will be 17 by 12. Also, another differences between the KU and the KD air handler. The KU will have both screw connection, so on the liquid line and on the suction line. And the KD only have one screw connection. The other one is you have to brace the suction line. Also, another big difference between those two is the KU comes already with R14A refrigerant inside the coil. So you have about 8 ounces of refrigerant already in the coil. Except the KD doesn't have this refrigerant inside of it, it's filled up with nitrogen. So just make sure you will purge this coil when we're talking about the KD before you do your brace connection. And also make sure the system will be refilled correctly after you have done your full installation. So on the torque side, again, because we're using screw connection, so we have only two pipe diameter that we will use. So the liquid line is always 3/8, and the suction line is always 3/4. Whatever like the tonnage you are installing, this is always the pipe size we will use at the time. So make sure you will use your torque wrench when you do your connection and apply the right torque for each connection. Also, because the coil is installed below the blower motor, the coil is in a negative pressure. So talking about the drain, you will have to do a P-trap to catch up the condensate water and make sure it will drain properly. So the P-trap needs to be located close to the coil or as close as possible to the coil, and make sure the drop like will respect the 2 inches minimum to catch up the water to hold the water a quantity of water to not let the air handler suck air from the drain. So this is really important to have a good drain evacuation. And also, you see here on the picture, we have some black cover over the drain pan. So we have four like this one. So if you see on the picture, there's a little slope to the right on this drain pan connection. So always make sure you will take the lowest connection to connect your drain. So obviously this is a upflow air handler installation, so you use the right side of the connection here. And also I used a small also just to drill my hole and make a good connection here. So my 3/4 PVC pipe here can fit perfectly inside, and there is no leakage, and it's done. It will do a great job. On the electrical side, when you open the panel here, the front panel, what you will see between a KU and a KD air handler, okay, is those black and brown wire here are your high voltage connection if you do not install a electric strip. So if you're using the air handler without electric strip, you need to keep this wired connection here, this Molex is already plugged, and then you just have to do your wire connection directly here. So it will be a 15 amp to 140 volt connection directly on the wire like this, and that will be good for an installation without duct heater. Also, the difference between those two cabinets is you can see on the KD air handler, the transformer is located outside the electrical board. For the KU air handler, the transformer is located inside the electrical board. So this is a big difference. When you will open the panel right away, you can see the difference between those two. If we take a look at the electrical connection directly here inside the box, so you will see here the KU, as I said, the transformer is located inside. The KD, there's no more transformer, it's located outside. And so you will have your terminal block here for your low voltage connection on the top right here in the box. And for the KU, it's directly in front of you, your low voltage connection right here. If we take a look at the connection, they use the same terminal board here. So the first one is your G connection to start up the fan. You will have just below your C and R to power up. That this is your power for 24 volt power right away here. So your common and your power on R. You have the W2 connection here to start the duct heater. And just below you have your B signal here for the outdoor reversing valve. And the D connection at the very bottom here is the defrost signal. When the system outside goes into a defrost, you can send back a signal to the duct heater, to the air handler, sorry, and says you are in defrost mode right now. On the other side, we will use the same display. So no differences between one air handler or the other. We use the same terminal block. So the same pattern is respected here. For the low voltage connection, there's a small schematic here that you will have to focus on, especially from the thermostat here to the indoor unit, or when it's connected with your outdoor unit. You will see this kind of connections everywhere. I added the KingHome thermostat to it. So basically, if you don't have the KingHome thermostat with the communication signal to the first floor, you will just have to forget about this part. Just focus on this part here. But what we want to focus on is sometimes, in regards of what kind of thermostat you are using, your aux connection here is the terminal for your duct heater. Sometimes you will have W1, W1, W2 aux. There's multiple kind of thermostat in the field. So you have just to mainly focus on what is your first stage of heating call when you will connect your thermostat. But if you are using the KingHome thermostat, this is a big difference here I want to point out, is we have a W and a W2 slash aux. If we are using the air handler, we will have only W2 aux connected from the thermostat to power up the duct heater. And that's it. So W will not be in use with the KingHome thermostat, only W2 slash aux. I also draw another, well, it's the same schematic, but I put it in here in a picture just to show you what will be in real life your connection. So maybe that will help you to figure that out when you are out on the field. With a KingHome thermostat, you will have a 4-wire connection from the main floor. So H1, H2, R, and C. And this wire, I suggest you guys to put it in the air handler. Okay, so you just have to throw this wire directly into your air handler, and you will match the connection here on the terminals. And those here are not on terminals. You will put some wire connections or wire marret or something like that to do your connection. From the primary thermostat, while using your KingHome thermostat, you will have, I suggest to use two different wires, one for a 4 wires to do your H1, H2, R, and C connection on one side, and you can have another wire driving the reversing valve, the compressor call, the fan call, and W2 aux for your duct heater. And if you have more optional like stuff like a humidifier, you can have an extra wire on HUM, for example, that is driving inside the air handler. So you can do all your connection here in the electrical box inside the air handler. And this is much easier to work with when all your connections are inside the air handler. So basically, you will have to throw like two different wire from the mechanical room to the air handler and just use the one from the main floor directly inside the air handler also. You can label your wire. This is also a great way to help you guys on a service call when all the wires are labeled. So which one do where it goes, and on the other side you will have your outdoor unit connected on the same terminal block. When we are taking a look at the board itself inside the air handler, You have some dip switches configuration to do if you want to change this the fan speed or your static pressure adjustment and this kind of stuff. So on a KU, there's two block here of dip switch, but only the top one will be in use. So you have this block here is called SA2. So this is the dip switch block SA2. So for your speed adjustment, the SA1 here is always on. So you don't have to touch the one here in the bottom. So only the first four on the top here that need to be adjusted accordingly from the dip switch configuration into the user manual. On a KD unit, well, the same kind of dip switch you see here, we have dip switch is located on the top left here, and we have another set in the middle of the board. So the middle here, the dip switch located in the middle here are the same one as those ones. So you don't have to touch those one. Only the top here that will apply the configuration. You will apply the configuration here for your speed adjustment. If you take a look in the manual, you will see a bunch of 0 and 1 like this for your configuration. So ACE A2 is your first block of dip switch you will have to adjust. ACE A1 for cooling speed, you don't have to touch in any air handler. So the KU, you will have the top selection here, and on the KD, it's the one on the top left. So because we're using different tonnage, there's different configuration. So if you're using a 2-ton, you will see here a bunch of 1 and 0. 0 means on, so position on. 1 means off. So basically for a 2-ton unit, you will see off, on, on. Okay, those ASA1 configuration here are always on position for both air handler. You will find the differences between a 2-ton, a 3-ton, 4-ton, 5-ton only for the heat at the first block here of the dip switches. So a 3-ton, it's on, off. So you will find it like this. There's 8 speed selection you can choose from when switching the dip switch. The default level is speed 4 for 2-ton, 3-ton, and speed 6 for 4-ton, 5-ton. On a KD air handler, you will have also the same kind of configuration, but a 2-ton and a 3-ton is using speed 4 as the default speed, and you will find the same configuration here. A 2-ton and a half and a 3-ton and a half, speed 4 as default, and this configuration here. So on, off. 4-ton, 5-ton, we're using a default speed 6 and this kind of configuration. And so to help you how to understand it, I suggest you just to flip your user manual on the side like this. And so you will find out the configuration much easier to understand. So basically, when you take a close look for a KU unit, you see the first block here, on, off. So basically, this is a 3-ton unit using the default speed 4 because it's on, off, on. Same thing here for a KD unit. So we have two different blocks. The one in the middle here is the ACE A1. We don't have to touch it. The one in the top left section is ACE A2. So if we take a look at this one, it's off, on, off. So basically, I have for this, this is in my training room. I have a 3-ton installed, Katie. So I have this configuration like in default. So off, on, off, off. So this is basically the easiest way to do it. So you just have to, when you will do your startup, making sure the configuration is good. You're not out of range, so you have to measure your static pressure and doing all the stuff from a good startup procedure. But making sure your configuration is in regards of the user manual correct with the CFM adjustment. Talking about the electric heater now, because we have two different family of air handler, we have two different family of duct heater. So the electric heater, just make sure you have the right one before you do your installation. So right on site, you will have to take a quick look at your model number and make sure it matches the right family. So for a KU air handler, we have these kind of kits. So there's a bunch of number here. So for example, 214227-00. Well, this is a 5 kilowatt heat strip, and this one's only referred to a KU family. For a KD family, you will see BLR 5000 watt slash 240 volt. So this kit here is only for the KD family. So basically, it's really important for you guys to make sure you matches the right heat strip with the right air handler family, and also take a quick look here at the heat strip that we can use versus the tonnage we have. So for example, if I have a 10 kilowatt, it's enough for a 3-ton, 3-ton and a half, 4-ton, 5-ton. I cannot install my 10 kilowatt here if I have a 2-ton, for example. I cannot do that. It's not inside the manual. So you need to focus on making sure you have the right heat strip, the right configuration before you do your installation. If we take a quick look at the duct heater itself, you will see for the KU family, you have all the white connection terminal on, like the stack on terminal here. They are all covered with a white rubber. And also you have your quick connection here. You have your breaker that is already installed. And if we take a look at the KD here, all the terminals are blue, and we are using heat relay instead of heat sequencer. So this is also another difference between those two family of heat strip. The KD is also equipped with a sensor. So there's already a sensor here installed with a wire, with a zip tie on this bunch of wire here. So you will have to maybe cut it, this zip tie. And you have a quick terminal here, so a quick plug. So you will have to connect two quick plug for a KD duct heater. So your high voltage here and the sensor. Some duct heater installation, when it's time to install the breaker, you will have like this metal hanger for the breaker. We have a split here with 2 screw. So if you're using 10 kilowatt or less, there is only one breaker that comes with. So you have to keep this black this metal sheet here, so metal bracket in place. Install your breaker, but if you have 15 kilowatt and more, so 15 and 20 kilowatt, you will have two breakers side by side. So you need to remove this metal strip here to make sure your breaker will be touching each other, so they will be side by side. On smaller tonnage, so this is a picture of a 2-ton. Because a 2-ton cannot handle 15 kilowatt, they make a smaller bracket, so only one breaker can hold here. So you have only one option is to install a 5 or 8 kilowatt in a 2-ton system, so only one breaker is used. You see here on the picture, there's one Molex connection here for the KU, and there's two here for the KD. So you have your high voltage white Molex connection, and you have the smaller one just behind it for your sensor, so your supply air sensor. So when you will install the dock heater, this is where I highly suggest to have access to the top lid. If you remove the top lid section here, this is much easier to install and work with this air handler. So basically, you will have to remove the electrical box. So there's two screws in front of the unit. Just unscrew that and just push the electric box away. You don't have to disconnect anything. You have enough wire to do that. The wire is long enough to do that. Remove this metal plate at the mounting hole here in the air handler. Then you will have this section here. So you remove the metal plate, you put your electrical box aside, and so now you can install the dock heater inside of it. In the back section here, you have two little holes, and the dock heater is equipped with a bracket. So make sure the two brackets fit in those holes to fix the dock heater properly. So this is really important. So whenever you push your dock heater inside of it, make sure the brackets will enter those two holes in the back of the air handler. When it's done, you can install your dock heater. So the dock heater is in place. You just put 4 screws to hold it in place. You can put back on your control board here. Then you will have to attach the breaker. So the breaker here comes with the unit. When it's time to install those breaker, you will see in the back of the breaker there's a white plastic piece that will help you to clip the breaker on place. So what is suggested here is you can use your screwdriver and just lift up a little bit so you have a hole inside of it. Just lift this plastic clip with your screwdriver, put the breaker in place, and then release it, and you will lock the breaker in place. So you need to be very gentle with this little guy. But whenever it's in place, it's locked. You cannot. So it's very a good connection when it's done properly. If you want to remove the breaker, you will do the same thing. So you will put your screwdriver inside the hole here, lift it up, and then the breaker will come off easily. But to install it, you will have to lift it, push it in place, and release this plastic holder so the breaker will be locked in place. If we take a look at the connection here, this is the schematic of the duck eater. So we have two different schematics. So I brought you here on the schematic two, this is 10 kilowatt heat strip for both of them. So for the KU family, this is the schematic for a 10 kilowatt. And the KD family, you have another 10 kilowatt here with the schematic also. So basically a 10 kilowatt only using one breaker. So you will have circuit breaker 1 only. You have your L1, L2 high voltage power. This voltage will apply on the sequencer. So you have a set of sequencer for your L1 and you have a set of sequencer for your L2. And then you have your limit switch, thermal fuse. You'll have all those kind of protection here if there's not enough air or the blower motor fell. Those protection will open and cut off the circuit for the heat strip. We have also, if you take a look here at HS1, terminal 2, you have a small wire here that going back on the quick connection plug. This is a feedback signal on the main board to tell the air handler that the contact is closed. So we have voltage here coming to the heat strip. So my heat strip is on. So this little guy here is a feedback to the board. So 1, 2, 3 is your high voltage connection. And there's 4 and 6 here for a low voltage control that will that will be your 24 volt from W2 aux will send out 24 volt here to the coil on HS1 and HS2 and then going back on the common. If we take a look at the KD, same kind of connection here, but instead of having sequencers, now we have heat relay, but they will use the same operation. So basically, L1, L2, a set of relay here called KM to have your high voltage connection. Again, the same kind of feedback to the board. So we're using the same stuff here. Also on the plug, you will have your low voltage connection. So 24 volt here on the terminal 4, and also you have a different one on terminal 5. So now the difference between this one and this one is if you want, you can cut off the wire here and you can stage up, you can stage your dog eater. So you can apply power if you have two-stage electrical heat on your thermostat. You can now stage it if needed. For installation with a 15 kilowatt and more, using two breakers. Now, you can see here on the schematic, this is a 15 kilowatt schematic. Same pattern, okay? Much more sequencer in that case. So 3 set of sequencer on each side. For your L1, L2, so you have circuit breaker 1, circuit breaker 2. And now to help you guys to do the connection, if it's a retrofit, so basically you have two different options here. From the electric panel, you can have two different power line. So in that case, for a 15 kilowatt, we are using a 30 amp breaker and a 60 amp breaker. So you can have from the panel two different power source breakers, so a 30 and a 60 amp. Or you can use this part here. This is called a single point connection. So because now the breaker are side by side, so remember guys, I said you remove the metal strip behind this single point connection. So now the breaker can be installed side by side. You can you can install this single point connection, and then you will do, for example, for 20, no, not for 20, but for 15 kilowatt, sorry, you can use only one power line with a 80 amp breaker directly from the electric panel. So this is different option that you can use if you have only one breaker coming, one power line from the electric panel to this connection here. You can have a 80 amp breaker on the single point connection. That's okay. And then you have your breakers side by side. On a KD, uh, no big difference. There's no big difference, but I told you, you will see on those schematic that you have X2. X2 is the temperature sensor. So located here, you have your temperature sensor. You have a wired loop of wire here with the zip tie. So you will have to cut this little guy here just to make sure you have a good connection for your X2 terminal here, to make sure you don't have any error, because if the uh, the sensor is not connected, you will have an error code right away when you will start the system. So basically, you have this connection here from the electric panel, and you have this connection here. You just have to clip it together. This connection is a speedway directly to the board right here. So the tube here connection, so the red connection here, it's only the same, that's the same wire right here. So what's going on with the electric heater when it's time to put it in place? So the relay here, there's a safety or like a trigger condition to power up your duct heater. So first of all, there is a feedback signal, and also from the duct heater, and also you need to have the fan running to make sure the board will give you the authorization to start the duct heater. So the fan blower must be active before you trying to power up your duct heater. So on the board, you will see two different connection. One, it's called X1. So from your aux connection, you will have 24 volts sending to X1, and then the internal section here will wait to have a the blower motor running before sending X2, the 24 volt on X2, on your plug to activate the duct heater. So this is really important. If your blower is not powered on, the duct heater will never comes on. So this is really, really important. Also, for a Katie, the X2 here, so your tube, your sensor inside the supply here needs to be connected also. There's a feedback signal from the sensor. If the sensor is not connected, you will have an error code. That's it. But basically, if you take your multimeter, and you trying to follow the 24-volt power. So from the thermostat, you will send out 24-volt when a command for your dock heater is sent. And you can follow your 24-volt here on X1. If you don't have anything on X2, that's because your blower motor doesn't have the feedback on the board. So regarding for the startup, this is important to take your measurement with your multimeter on L1, L2 before you flip the breaker switch on to on position. So make sure you have the proper voltage to the air handler. If it's a commercial application, sometimes you will have 208 volt in use. You can modify the transformer wire to the board if you're using 208. So basically, the transformer is using 3 wires. Um, you can select if you want to use the black wire. Well, the black wire is installed in as a default for 230-volt. But if you have 208, this is important to switch the black wire to the blue wire on the terminal X13. So basically, that will help the transformer to work with the proper voltage and gives you a real 24-volt output. The systems will run, for example, if you have 208 in your application, but you forgot to switch the wire from the black wire to the blue wire on the transformer, that will result by gives you maybe 21 or 22 volts only from the transformer. So you will not have a proper 24 volts coming out of it. So that will not like break the system or fry the board or anything like this, but you won't have 24 volt at the output. Also, when you will do your startup and you start up the fan, you can take the amperage with the clamp meter on your L1 and just make sure the fan motor is like having the right ampacity. So from a KU series, we have 2 different blower motor, one with a 4 amp ampacity, the other one with 8 amp ampacity. And the for the KD family, we have different blower motor regarding the tonnage. So on this chart, you have different amp what we are looking for. So basically, the blower motor ampacity must be lower than the number you have on this chart. There's also LED indicator on the board. So when you will power up the system, you will see a couple of LED light glowing on the board. You will see a red color, a red LED. This just means the board is powered on. Okay, so basically the red LED is just for to tells you the board is active. You have also a green LED. So this one tells you the systems you have a turn on system. So now the system is running. Uh, if you don't have any call on the system, this light will turn off. You have also a malfunction chart regarding those, this green LED. So for example, if you see this green LED flashing, you will have to count the number of flashes and then take a look inside the user manual, and maybe you will find your error codes regarding this green LED. So, for example, if you have changed a board and you forgot to change the blue jumper cap, right away you will have only one flash. So light out for 3 seconds, then flash once. Again, goes off, flash once. This means the jumper cap is failed, or you just have forgot to replace it when you have changed the board. If there's two flashes now, this indicate an indoor fan failure. If the inner tube sensor is failed, you will have four flash. And then if you have forgot to attach the indoor air outlet temperature, so the one that comes with the duct heater, you will have six flash. So that indicate the error code directly with the green LED. You will see also a yellow one, but only when the fan is running. This is a signal for the RPM of the motor. So you will see also a yellow one, but this one will flash, sometimes stop, sometimes flash. It's just the feedback from the blower motor. So you don't have to worry about this one. Only focus on the red and the green one. So when it's time to do the test, I suggest you can put a jumper on your connection right away. So between R and G, and start the fan. So make sure your fan motor is working properly. You have already adjust the CFM, so your dip switches, your static pressures. You have taken your static pressure, and so by using a jumper between R and G terminal, that will start the blower motor. Then you can add another jumper on R and W, and that will start the electric strip. There's no time, there's no wait, like it will start right away. Okay, so there's no delay, or maybe a couple of milliseconds. But whenever you apply power between R and W, and the blower motor is already running, well, your duct heater will start without any delay. Um, Make sure also you will take the amperage on your L1 power line. So from the electric panel, or if you have a disconnect switch, or if you have anything else regarding on the breakers already installed in the air handlers, take the amperage of your fan motor and take the amperage of the electric strip. So take notes of your data. This is always recommended to leave a checklist just beside the air handler when you have done your startup, and you will have around 20 amp per 5 kilowatt for a 5 kilowatt uh, duct heater. So 20 amp per 5 kilowatt plus the air handler blower. So this is what we are looking when we have a air handlers running at full capacity with the duct heater active. So for example, if we have a 2-ton system with a 5 kilowatt inside in it, so I'm about to see around 24 amp ish. Really depends on the static pressure, really depends on uh, how the system is installed, but around 24 for this kind of installation for a 2-ton with the 5 kilowatt. Also, because the static pressure is really important, we have to take it below the coil in the return section. So basically, if you have a bed installed below your air handler, you can drill some hole inside this bed and take uh, your static pressure over here. If you want, you can pierce like 3 different holes and make an average of all your return section. And same thing here on the supply duct. So making sure you will drill a hole here and make the reading of your static pressure of the entire air handler right here. So if you are using only one tube, you will have to like compare to addition to make an add of those numbers together to have your total static pressure. But make sure you will compare your data with the chart inside the user manual. This is really important. And also because we have a dock heater installed in this section here, when you will take your supply air temperature inside the plenum, inside the supply duct here, it's always good to make sure you take your measurement for temperature after the first elbow. So basically about 3 feet away from your duct heater, because you don't want to install the probe directly on top of the duct heater. That will give you false indications of your temperature, because you will gain also heat from the radiation, so directly on the electric element. And if we want to have a proper reading of the temperature in the supply duct, you have to be like 3 feet away from the duct heater to avoid having the radiation readings also add to the temperature. I just want also to talk about the KingHome thermostat. Um, the KingHome thermostat here, there's 2 different configuration that you can do with this one. You can select it inside the thermostat if you have a gas furnace, or you can select an electric air handler. Inside the configuration, there's some configuration related to the electric air handler and some of those related to a gas furnace. So for a air handler, we will focus to adjust the parameters 6 to 9 here, only for the electric air handler. So there's different application here that we can select. So aux means your heat strip. So for example, aux on timer, I can select 0 from 120 minutes. This will help me to like give more comfort for my customer. So for example, my heat pump is running. I can use both simultaneously, because now my indoor coil is in the return air section. I can use my heat pump and my duct heater simultaneously. So basically the auxiliary heat, or at this point, is just an add to make sure you will reach the set temperature uh, more quicker. But you can adjust the timer from 0 to 120 minutes. This will reduce, for example, the not reduce, but that will help the customer to reach out the temperature after a certain amount of minutes. So for example, if you set it to 60 minutes, the heat pump will have to run 1 hour before the duct heater have rights to be enabled. Number 7 is maximum activate temperature for aux. So this is regarding the outdoor temperature. So if you have the Wi-Fi connected or a outdoor sensor optional connected to the system, we will take a reading of this outdoor temperature, and between 10 and 30 degrees Celsius, you can apply a limit to start the duct heater. So for example, if I set it on 10 degrees Celsius, if it's more than 10 degrees Celsius, my duct heater doesn't have rights to run. Aux on temperature differential from 0 to 5 degrees Celsius. So basically, this is a difference between your set temperature and the actual room temperature. If you put it on 2 degrees Celsius, for example, it's 20 in my room, and I ask for 22. Now the heat pump and the electric heater can be active simultaneously because I asking for 2 degrees, more than 2. And so I can put this difference higher, so to 5 degrees Celsius, if I want to focus on energy savings. And basically, I can put it nearly 0 or 1 if I want to bring more comfort to my customer. Number 9 is satisfy room temp with auxiliary heat. So this is only a reverse stage, if I say so, saying that if it's if it's yes selected, you will keep the electric heat active till you reach the set point temperature. If it says no, then your duct heater will turn off when the temperature is close to the set point. So basically, that will also add more energy savings to the system, because we want to turn off the duct heater most of the time, but if needed, it's there to help the systems to perform. So this is about the thermostat. Now it's time for you guys. If you have any questions, if you want to talk about some issues or some questions you have face right now about those installation. Now it's your turn. So basically, it's focus on the errandler only. So please, we will talk about this only. And but now it's your turn, guys. If you have any comments or questions, now it's time for you to ask.
Hey, Francois. Sorry, just looking at the chat. There were a couple of questions that I didn't want to interrupt you as you were just going on with the presentation. But Alex has asked a question: the KU come with a single point attachment kit automatically, or is it an add-on for the 2 breakers?
This is an optional part. So the single point must be purchased separately, because it's only in use when you have a 15 kilowatt or a 20 kilowatt only, and in regards of what wires coming out from your electric panel.
Well, I hope that answers, Alex. Again, feel free to jump in the conversation. Hopefully that answered your question. I got another question from Byron, Francois. Are they breakers or just disconnects? It goes on to say, electrician on our previous install noticed that they were labeled with any of the information to make them a breaker. Like she's going through I would imagine they're just breakers.
Yes, they are breakers.
Chris asks, is there a 3-phase option for the heat strip kits?
No, it's only single phase.
Yeah, I kind of saw that in the presentation as well. And that's pretty much it. Not too many questions in the chat, but again, now's a good time if anybody has any questions before we go. As we got Francois' attention today, but if there's nobody out there that has any questions, Francois, again, my friend, thank you so much for taking the time this morning. I know it was Friday and all, but again, appreciate you again spending the time with the group today. And there's a lot of information in there, so good stuff.
Yeah. Also, the presentation is available to you guys, so whenever you want to refer back to like the schematics and the dip switch, so there's no so you will have access to this presentation as well.
Yeah, that's great. And what I'll do is I'll have our friends at the tech, John Dirksen at Tech Desk, he'll dump this presentation into the Google Drive.
Yeah.
Again, I've recorded today's session, which will be available through our LMS system. So again, for future references, we've got this presentation, and which is great. So again, Francois, I appreciate your time. I appreciate everybody's time today. This will be, I think, our last training session before the new year, leading into Christmas or the holidays. And I just want to say Merry Christmas, everybody. Happy holidays. Francois, thank you again, my friend. And
yes.
I just have a quick question. Sorry to interrupt.
Oh yeah, sorry, I didn't see that. I didn't see your hand up there. Sorry.
So the single point attachment, a lot of times we have a electric air handler, 100 amps coming down. Is there specs on it? On what size wire it can take? Yeah.
Yes, it's good for 100 amp.
Okay.
This connector here. So I think you have it right here.
Oh, perfect.
Yeah, you have some range here for your wire if you use aluminum or copper wires, and also the torque you need to apply when you will torque those wiring. Also, another thing that this quick connection, single point connection comes with, you can connect it from the side or from the top. Because the top lid here, you have a metal insulation here, you have insulation with the aluminum sheet on it. I suggest you guys to leave the plastic protection here from the top, so don't remove it, and do your connection here on the side of the single point. That will also help you guys. So from both sides, you have enough space to make a S shape to your wire, if I say so, or it looks like a small hook, and then you can have your connection. This is a connection with a Allen key, so you will have to apply the right torque after that. But I already did some tests. So when you close the lid here, the top lid of the air handler, and you have the single point, there's no problem at all. So you just have to keep this plastic protection here. So just remove the one from the side.
Thank you.
I think we have another questions here.
I saw Darren's hand up. Darren, do you have a question?
Yeah, just a quick one. For sales purposes, for matchups for outdoor heat pump and indoor air handler, are we just going ton for ton, or is there a matchup sheet? So, example like Lennox might have a 2-ton outdoor heat pump with a 2.5-ton, 3-ton indoor air handler. Are we just going straight ton for ton? So if it's 3-ton, it's 3-ton?
You can, well, it's always better to do the same tonnage, but it's really in regards of your CFM, what you need. So for example, you can go an half ton higher for your air handler. Basically, it's really depends on the static pressure of your ductwork and also the CFM requirements. So for example, and you can mix and match the series also. So you can have a KU outdoor unit with a KD air handler. So for example, if you are using a 2-3 ton KU outdoor, you can match it up with a 2.5 ton, 3 ton, 3.5 ton air handler. So with the KD series, that will give you more flexibility about the amount of CFM or the requirements you need for that house. So basically, with the dip switches, you can also select the exact fan speed you are looking for.
Okay, perfect. Thank you.
Francois, just to add on to Darren's question, would you and Rachel be able to share a matchup, so our EMCs and our installers have we're reading from the same document saying these are the requirements of the matchups, and so like I just had one yesterday where the EMC did not order the indoor electric strip, but he had the air handler with the fan coil with the outdoor unit, but they required the electric strip, and they didn't order that in on their order.
You mean a matchup for the right duct heater, or a matchup for the indoor capacity versus the outdoor capacity?
Indoor capacity versus the outdoor capacity, but also I'm going to say probably maybe getting getting connected to Rachel, getting connected with Derek Brown, and putting together a kit based on whether it's an electric strip requirement or non-electric strip, and we're just using a fan coil with with the outdoor unit.
Okay. Yes, I can build up a chart for you.
Yeah, that would be good.
Just because we're getting just because we're getting new into this, I know some areas have dealt with this for many years, but there's a lot of us that have not had practice with installing the fan coils with electric strips and heat pumps. So we're behind. We're behind, a little bit behind.
Yeah, no problem at all.
But yeah, that'd be good too for us, because like say hypothetically you have 20 kilowatts of heat you need, so our guys would need to know the minimum cabinet should be like 3 ton or whatever, right? You can't put a 20 kilowatt with a 2 ton, right?
Well,
so we need to know the matchups.
No, we're trying to avoid the 20 kilowatt. To me, to make it serious, guys, 20 kilowatt is really overkill. We're trying to avoid installing those 20 kilowatt because it's only matching up with a 4 ton or a 5 ton air handler, and also that will gives you sometimes, not, I don't want to say troubles, but the circuit breaker for 20 kilowatt needs to be 125 125 amp. So it's a big wire to run from the panel for only a 20 kilowatt. So especially for those kind of system, a 15 kilowatt, well, it's well enough. It's well enough that with a 15 kilowatt, you will reach out like about 51,000 BTU. So this is clearly enough for a house to use a 15 kilowatt. So 20 kilowatt, it's really overkill. But just make sure if you need a 20 kilowatt, just make sure you have a 4 ton or a 5 ton attached to it.
Mm-hmm.
But yeah, for sure, John, I can gives you a mashup for the indoor capacity versus outdoor capacity. There's no problem. I can do that.
Fantastic. Yeah, and just just do the mismatch of the KU outdoors versus the KD indoor. That's exactly what I had with the Hamilton crew the other day. But we were just missing the electric strip. That was the shortcoming.
Okay. No problem. I can build you like a chart with all the kits that you can do.
Fantastic. That would go a long way. That's for sure.
Okay, great, perfect,
awesome. I think I saw Chris Wanamaker. Chris, did you have your hands up there, bud? Or You put your hand down, or what's up, Chris?
I just had a question about the sizing thing, like this 15 kilowatt being enough in a house. It's not in many cases. So you've got like a house that needs 2 tons of cooling. It's going to need most of them in Kingston are going to need more than 50,000 BTUs to heat the house. So
The boys, you jumped the ball already? Or got around 7:30. Yeah, you gonna take her?
Yeah.
Hop, little
you-
bunny, hop, hop, hop.
But you have to just take note that both systems will work together. So you need to add the capacity of your heat pump plus the duct heater. So this is the way to calculate your heat load when you are installed this kind of system, because they will run together. So for example, if you have a 2-ton KU system with a 10 kilowatt, okay, you will have about like more than 40,000 BTU developed at -10. So basically, you will have to refer to your load calculation and then just apply the right air handler to it to match with the duct heater. Because the thing is, if you are underflow, you will have some troubles with your duct heater. So the limit switch or all the protection inside of it, if you don't have enough air, the heat strip will not work at the end of the day. So basically, you have to focus on the airflow needed in the house. So the number of register you have, the capacity of your ductwork, and then you needs to apply the right air handler with this situation.
When you were saying the BTU content you were getting out at -10, do you guys actually have a chart for that? Like,
Yes.
'cause they don't do. Can you send that out? Because we don't do full manual J's when we're selling a system. We do a a heat loss calculation, but we're not going to have access to what BTUs we get out at certain
We have all
temperatures.
that. I think you, John, you already have the chart, the capacity chart for the KU and the KD.
Yes, it is. It's in Google Drive.
Yeah, okay.
If you could share it
So-
with me again, I just want to validate that I have the correct charts in there.
Yeah. Okay, I can send it to you again. Yeah, no problem.
Awesome.
I think that's it. I don't see any hands up.
Okay, so thank you,
Perfect.
guys.
Yeah,
Happy
thanks, Francois.
holidays.
Again, yeah, happy holidays, everyone. And
Be
again,
safe.
Francois, we'll see you in the new year. We'll see everybody in the new year. And I know just before everybody goes, I know Francois did introduce that the KingHome thermostat to our group this morning. That thermostat's right now, as we speak, is going through our new product phase. We're expecting it to, maybe see that sometime in the new year. I don't have a set date for it just yet for everybody on the phone, everybody on the call, but expect it sometime in the new year, I would imagine, as we're going through the new product phase. So I just wanted to give that shout out to everybody. So with that said, I'm going to say good day. Thanks again, Francois. And again, thank you all for joining us this morning. Good session, Francois.
Okay, thank you, guys.
Thank you. Bye, y'all.
Bye.
Thanks very much. Bye.